Welcome all. In our next presentation, I would like to welcome two members of the WorkSafe Victoria team, Albert Chemali, Manager of Chemical Safety Planning, along with Jaime Thompson, Senior Process Safety Analyst. Albert joined WorkSafe Victoria 8 years ago and has held roles as MHF Inspector and Process Safety Analyst before taking on the Manager position for the Chemical Safety Planning team. Jaime has more recently joined WorkSafe Victoria, however has more than 14 years experience in the offshore oil and gas processing industry. In this presentation, Albert and Jaime will share the evolution of Victoria's MHF regulatory regime and how WorkSafe Victoria uses 20 years of data to shape their regulatory response. Please welcome Albert and Jaime.
Thanks, Yvette. Hello, my name is Albert Chemali and I'm the Manager of the Chemical Safety Planning team at WorkSafe Victoria. The Chemical Safety Planning team is predominantly made up of process safety analysts that conduct safety case assessments. The planning team focuses on the capture and analysis of data to further inform our regime. The team also manages the Major Hazards Program procedures and looks at resource planning, especially during our peak licensing periods. The intent of today's presentation is to provide you all with an overview of the MHF regulatory regime and how has it adapted and changed over the last 20 years. The presentation will be divided into two main components. The first part I will be speaking to will hopefully provide some history about the MHF regime. I will highlight some of the key changes that have occurred during the time, and I'll also touch on some anecdotal observations that we have observed during this time. Jaime Thompson, a Senior Process Safety Analyst within the Major Hazards Program, will then take you on a data journey and highlight some of our findings over the last 20 years. I would also like to take this opportunity to thank Mirella Halilovic, our Chemical Safety Analyst, who pulled together most of the data for today's presentation. First of all, I will just give you a real brief introduction into the MHF program and how we were formed. I appreciate that most of you have heard this story a number of times, so I will try and capture the key points as quickly as possible. The Major Hazards Program was formed following the recommendations made by the Royal Commission that investigated the Longford incident that occurred on the 25th of September 1998. The Commission made a number of recommendations in its report. However, there was one key recommendation that formed the basis for the development of the Major Hazards Program as we know it today, and that is the one that you can see up on the screen. And I'll just read that out real quickly. The Commission recommends that a safety case or safety report procedure of the kind identified be extended by legislation to all major hazard facilities within the state, and that a specialist agency sufficiently independent from the Victorian Work Cover Authority to avoid any conflict of interest be established to administer that procedure. From that recommendation, the Major Hazards Program was born, and as you can imagine, there was quite a bit of pressure to quickly begin drafting the first set of regulations, as well as developing all the procedures and processes and procedures that form the basis of the work that we do today. As you may know, the Major Hazards Facility Regulations came into effect in July 2000 and were based on the 1996 Australian National Standard for Control of Major Hazard Facilities, which in turn had been based on the Severity 2 framework. During these early days, the Major Hazards Program focused on ensuring the team understood the regulatory requirements and what compliance looked like. And the team also spent a fair bit of time delivering seminars and communication to industries in a bid to try and educate them on the regulations. Having heard the stories from a few people on both sides of the fence, I think it's safe to say that it was a very busy time for all due to the tight timeframes and the steep learning curves. Years later, our regime has remained largely the same. However, there have been some changes that are worth highlighting. Over the last 20 years, there have been three sets of MHF regulations, the 2000, the 2007 and the 2017 regulations. For the most part, the regulations have stood the test of time, with some minor changes where regs have either been rearranged, moved around or fleshed out a little bit to provide more clarity. However, the overall intent of the regulations has remained the same. Some of the more significant changes worth noting are one around the requirement of safety roles to be considered when undertaking modifications, changes in the classification types and quantities of scheduled materials, one example being the recent addition of phenol to Table 1, MHF licensing fees and additional fees associated with transferring or amending licenses, the ability to extend time when making license decisions, and the ability to withdraw a registration of an MHF. Other things that have changed is our approach to regulation, MHF regulation, including what we would consider as compliant. And I've tried to highlight some of the key ones on the following slide. Early in the regime, the team focused purely on critical controls and did not look at other controls. This was largely due to the fact that the team had no data points at that point in time, and so the focus was really on those higher order controls that the MHFs really relied on. These days, as most of you would be aware, we focus on all control measures. However, we still have a slightly more of a focus on those more important controls. Our approach and relationship with MHFs has differed over time. Over the years, the team has alternated between having a more collaborative approach, an educational approach, into a more firmer enforcement approach. This is an area that the team continually discusses internally as we continue to strive for the right balance between education and enforcement. There's also been a number of process changes that have occurred within the Major Hazards program over this time. The way we assess safety cases and document our findings has been streamlined to ensure that we focus on key areas and that we document our findings in a more consistent way. We have developed more in-house guidance for process safety analysts to ensure that we're being more consistent in the assessment of safety cases and what compliance looks like. We've integrated our assessment, annual inspection and oversight activities into a whole licensing cycle to ensure that we have consistent touch points with the MHFs over that entire licensing period. And we have increased our efforts in providing proactive information to our MHFs in a bid to try and iron out any issues well before license panels. And some of the examples here would be the development of the oversight history report that highlights the key issues and focus areas for the site as they're going through the review and revise process. Development of newsletters such as MHF Matters and safety alerts provide MHFs with information around incidents. And finally, meetings with senior management and chief executives to ensure that major hazard facilities have the right backing and support from an organisation. Recently, we have also invested a fair bit of time and effort into our data capabilities so that we have less of a reliance on people having to identify trends and instead allowing our data to highlight those key areas for us. Another key and arguably the largest change over the last 20 years is our expectations as a regulator and what we consider to be SFARP, or so far as reasonably practicable. Learnings from incidents has taught us a lot about hazards and controls. The most obvious one being the Buncefield incident that occurred in December 2005, which taught us about the importance of independent high-level alarms and gas detection. The findings from these incidents was one of our main focus areas for round 3 and round 4 licensing. Changes in technology and its costs have affected our expectations. As an example, gas detection technology over time has improved and reduction in costs has also occurred. And also a reduction in spurious trips, which have made it more practicable to implement gas detection on site. Changes in technology has also impacted our focus. And an example of this would be our recent focus on cybersecurity during our annual inspections. Changes in codes and standards, such as Australian standards or NFPA standards, have guided and influenced what we consider compliant. Another example of that would be the recent AS 1940 change, which lowered the acceptable radiant heat exposure to emergency personnel from 4.7 to 3 kilowatts per metre squared. And finally, changes in industry standards or internal organisational standards have also changed our expectations of MHFs. And I think performance monitoring is a good example of this, where sites have moved away from the previous rudimentary activity measures and moved into more meaningful KPIs on sites. And another example of this would be how sites have used their own data from their own control measures of their controls rather than to rely on data obtained externally. And it is these points that I've just discussed that have really helped shape what we as a regulator consider to be SFARP. And in turn, it's these observations that provide us with the basis to have more robust conversations with our MHFs and have hopefully helped guide the industry in the right direction. Shortly, I'll be handing over to Jaime to begin speaking about the data that we have collected and analysed for the forum. Whilst Jaime is taking you through the data, it is worth reflecting on some of the changes I've discussed, as these have no doubt contributed to the results in some shape or form. The difficulty for us as a regulator has always been how we measure how effective we are. Obviously, we are one step removed from site operations, and therefore relying on site performance as an indicator of our performance may not always be the right approach. Some of the data we'll show you dates back to 2003, which is when we first started collecting information in the Major Hazards Program. As time has progressed, we have further refined how we collate our data, and more recently, we have taken our data collection down to another level, allowing us to have more deeper insights at a more granular level. Jaime's presentation will touch on some of our findings over the last 20 years. However, the intent of the presentation is to give you an overview of the types of data we collect, but more importantly, whether the data tells us anything about the MHF regime and how the regime has impacted on the performance of MHFs. One of our goals for the future is to share our findings from the data at an industry level and also individually at a site level. I will now hand over to Jaime Thompson to take you through this exciting work that we are keen to share with you. Thank you, Jaime. Thanks, Jaime.
Thanks, Albert. As Albert touched upon earlier, up until now, WorkSafe Victoria has relied heavily on process safety analyst knowledge and the combined evidence that we've collected as individuals to determine areas where sites may need to focus their efforts with respect to safety performance. However, there's recently been an effort in-house to try to extract and use the vast amounts of data that we've collected over the past 20 years to improve that process and also provide a semi-qualitative way of measuring the safety performance of MHF sites, as well as the safety case regime in Victoria. The main purpose of which is so that we as the regulator can adapt as needed to focus on the areas that really matter and work more collaboratively with our sites. Before we dive too deep within the data and the findings of the work completed, it's worth touching on the number of MHFs we have in Victoria and how that's changed over the course of the last 20 odd years. By the end of 2003, at the very start of the Major Hazards Program, Victoria had 37 licensed facilities, which increased to 44 by the end of 2007. As of 2021, we have 38 licensed major hazard facilities in Victoria, with 2 additional facilities registered and going through their first safety case assessments this year. During this time, the petroleum processing and storage facilities have made up a majority of these sites, accounting for almost half of all the MHFs licensed over the past 17 years. A third of these licensed sites are from the chemicals and plastics industry, with utilities, logistics and explosive sites making up the balance. Overall, this split has been reasonably consistent over the last 20 years, although Victoria did see a reduction in explosive sites after 2010. And for the first time in 10 years, we have 1 licensed explosive site as of 2020 and another one registered and going through their safety case assessment at present. Since the safety case regime was introduced in Victoria, WorkSafe has collected data in a number of different forms. Through the safety case assessment and verification process, we collect a timeline of data for each of the sites that provides a real visual into how the site's safety case has developed and improved, or in some areas struggled, over the course of the site's involvement in the regime. Collectively, looking across a number of MHFs that have been part of the safety case regime, we can also use this data to understand common areas that sites struggle to gain compliance. During the course of a standard 5-year licence period, sites will undergo 3 annual inspections. During this annual inspection, the performance and effectiveness of a number of control measures and SMS elements are inspected. There's an abundance of information contained within these annual inspection findings, and we've recently started using an in-house tool to extract some of this data in a way that will provide us with a better overall view of the performance of each site. Additionally, WorkSafe Victoria also collects data associated with notifiable incidences, and we've been doing so since the start of the regime. With all this data available and recorded within our systems, as we mentioned before, there's been a drive within WorkSafe to use this information in a way that can allow us to look at the historical data and use this as a lead indicator for potentially emerging issues. The aim of this work has been to analyse and assess the data in such a way that we can use it to actively assist in providing some insight into the performance of individual MHF sites and those within similar industry sectors, identify areas of improvements for both individual sites and collectively, provide some insight into the performance of the safety case regime over time, and use it to target training and industry information that we provide to sites. The initial focus of this work to date has been centred on the information collected from the notifiable incidences and the annual inspections. Since the beginning of the regime, WorkSafe has been collecting and recording the Major Hazard Facility Notifiable incidences. Amongst other things, the key data that we record includes the location and date of the incidents, descriptions and outcomes of the incident, and if it involved scheduled materials, the primary or root cause of the incident, and the incident severity classified as either serious, significant, or minor. Serious incidences are those incidences that resulted in or had the potential to result in a major incident. In other words, it posed a serious and immediate risk of fatality to personnel. Significant incidences are loss of containments of 10,000 litres or more of dangerous goods, which did not pose an immediate or serious risk of fatality to personnel. And minor was pretty much captured all the other notifiable incidences under the OH&S Act of 2004. These are typically associated with small loss of containment events of dangerous goods. With respect to the annual inspections, WorkSafe has been completing annual inspections in much the same way since 2003. Process safety analysts review the site's safety case, and from there we select a range of control measures and SMS elements to inspect. A range of questions are then asked in order to establish if the control and SMS element has been implemented as described in the safety case, and if there's sufficient testing and monitoring to ensure that the control or SMS element is functional and effective. Each control and SMS element is subsequently rated on its implementation and functionality in a qualitative way, either fully implemented and functional, partially implemented and functional, or not implemented or not functional. To date, work completed by WorkSafe Victoria with respect to analysing this data has used a sample set of all the Major Hazard Facility Notifiable incidences involving Schedule 14 materials since the start of the regime in 2003, and a sample set of approximately 80 to 90% of the AI data collected since 2008. From the vast amounts of data that we have, there's a lot of interesting findings, and not all of which we'll have time to go over today. However, one of the interesting things we did discover was how the number of notifiable incidences have changed since 2003 and how different industry sectors have performed over this time. As a result, we decided to look into the annual inspection data in a way to see if we could find any insight into what we were seeing in the notifiable incident space and if there were any recent trends that were worthy of noting. It's important to note before we dive into the data that the approach taken by WorkSafe in some areas is semi-quantitative and has been used in a way to simplify the data in order to assess the extensive amounts of information we've collected, particularly when it comes to annual inspections. However, when it comes to the number of notifiable incidences we record, the sample size of data we have isn't that great, which isn't necessarily a bad thing when we're talking about incidences. We recognise that we're effectively only seeing the top tier events when it comes to incidences, and we're not privy to the abundance of near-miss data that each of the sites collect independently, which could be used to flesh out some of these more complex issues. The data that we're using on its own does not, and it should not be used as a finite measure to measure the success of the safety case regime or use it as a scorecard for major hazard facilities, because there's a lot of things that can't be measured, such as the way a regulator's expectations may change over time. Rather, the intent of the tool that we've developed is to use it alongside the expertise of our process safety analysts to provide insight into the regime, trends we're seeing in data, in order to provide a better focus and improvement in the way we work with our sites. So firstly, looking at the data that we've collected for notifiable incidences from 2003 to 2020 and taking a simplified average number of notifiable incidences per MHF site per year, we can see that in the initial phases of the safety case regime, we saw a considerable decrease in number of incidences per site between 2003 and 2016, with overall an upward trend starting to begin around 2017, which we'll focus on a little bit later. As expected, a majority of these incidences are associated with minor incidences, typically very small loss of containment events. 10% are associated with significant incidences, those larger loss of containment events, and only a small percentage of the incidences recorded were classified as severe, i.e. those that resulted in or had the potential to result in a major incident. As much as we at WorkSafe would love to take the credit for this steady decrease in notifiable incidences, the reality is that the reduction in the incidences is likely due to many factors, such as the maturity of sites and the industry over the last 20 years, improvements in standards and technology, and learnings from the industry incidences. However, the safety case regime does ensure that major hazard facilities are continually abreast of the site's risks by ensuring that they continually review these hazards and challenges in their previous assumptions. Interestingly, over a similar time period that WorkSafe Victoria saw a continual reduction in incidences, the data recorded from annual inspections found consistent improvements, particularly across key SMS elements, as we see here. Annual inspections of sites' management of change systems, training systems, permit to work systems, and incident and non-conformance management systems all saw consistent and gradual improvement over the last 10 years. It's important to note that the scoring here, as we mentioned before, is semi-quantitative, based solely on the final rating of each SMS element reviewed. A mark out of 3 is essentially given to both the implementation rating and functionality rating and added together for a total score out of 6. What this data doesn't exactly quantify is how WorkSafe's expectations have changed over the past 10 years. In other words, we believe our expectations of sites and their systems required to manage safety have increased during this time as well. And hence, overall, we consider that the sites have made meaningful progress and improvements when it comes to these key SMS elements. The improvements within the management of change system and incident and non-conformance management systems are worthy of noting. As the primary use of the management of change system is to provide careful evaluation and control when changes are proposed at facilities, we see that when there's a robust system in place, it provides a solid foundation for the identification of potential new hazards. It allows for mitigation and prevention measures to be implemented, and as a result, we see a drive in process safety improvement performance and overall a reduction in the potential loss of containment events. Similarly, when sites have good non-conformance and incident management systems, issues identified during inspections are rectified quickly, and incidences or near misses that do occur on sites are appropriately recorded and investigated, with the findings and improvements made to decrease the chance of repeated events. Another area that WorkSafe Victoria were interested in when looking at the incident data was the impact of different industry sectors have and their corresponding contributions to notifiable incidences. If we go back to the incident data, again, looking at the simplified graph, just showing the average incidences per MHF, we can see here that incidences from the petroleum, storage and processing industries account for about 65% of all the incidences we record, with chemicals and plastics almost 30%. These results are hardly surprising, given, as we mentioned before, the distribution of sites is very similar. Therefore, what we see when we normalise the number of incidences per site based on the number of MHFs in each individual sector is this. Although we found a little bit of variation in the number of incidences for each sector from year to year, or in this case, what we don't see is a standout sector. In other words, based on the incident data we have, each sector is performing on average on par with each other when it comes to the number of notifiable incidences. This is really an interesting finding when we consider the complexity and size of some of the petroleum and chemicals and plastics processing facilities with the comparatively simple operations that we see in utilities, logistics and explosive sites. Again, when we had a look at the annual inspection data and those key SMS elements, what we see is that over the course of the last 10 to 12 years, on average, the petroleum and chemical plastic sites have continually showed better annual inspection performance with those key SMS elements. These larger and more complex sites are often more mature when it comes to the process safety. They have well-defined SMSs and have dedicated process safety resources And they're often supported by large international corporations with extensive operational history throughout the world. Because of this, they're often very familiar with the requirements of safety case regimes and have mature and very well organised systems in place to manage risk. This is compared to the utilities, logistics and explosive sites that are sometimes relatively new to the requirements of process safety and possibly less mature in the development and implementation of their SMSs. And although they are performing reasonably well, they often experience a really steep learning curve when they're determined to become an MHF. So if we once again go back to the incident history over time, we mentioned previously about this increasing numbers of notifiable incidences that we have seen over the past 3 years between 2017 and 2020. Subsequently, this led WorkSafe to look at the root cause of these incidences to try to get a better understanding of the issues that are being reported. In doing so, the historical incident data was reviewed and the root causes were categorised into one of 5 groups. Asset integrity failure. These are essentially incidences that occur during normal operations, often spontaneous loss of containment events initiated as a result of corrosion, pump seal failure, or just a failure to maintain engineering controls, such as a pressure relief device. Process upset and engineering design. These are incidents associated with an inherent engineering design defect or a failure to adequately identify a process hazard pathway and hence a suitable control measure to prevent loss of containment. Procedural failures. These are typically incidences associated with either maintenance activities or interventions where a procedure or safe work practice in place was deficient in some way. Operator error or training. Again, these are typically encompass incidences associated with either maintenance activities or interventions where an operator did not follow a procedure which was adequately in place. In addition, it may also cover areas where an operator was not competent to do the tasks or they were not provided with sufficient training. External interference is, as you would expect, typically loss of containment events as a result of some form of external interference, such as an impact from moving plant or a dropped object. As often is the case with these incidences, there's normally more than one root cause, and in which case we've taken a judgment call based on what we saw and accounted it to the most relevant one. In this instance, the findings from this work, we can see that incidences associated with asset integrity have accounted for a majority of all incidences across the time period that we've looked for, usually greater than 50 to 60%. By further examining these asset integrity incidences, particularly between 2010 and 2020, and yet again normalising the numbers based on the number of MHFs we have in each industry sector, we see for the most part that the petroleum industry consistently has more asset integrity related notifiable incidences compared to the other industries, sitting above the mean consistently over the past 10 years. This finding in itself seems reasonable when again we consider just the sheer volume of equipment and assets our petroleum sites and our chemical sites need to manage when compared to the smaller utilities and logistics sites. However, some recent asset integrity related incidences at some of our sites that have implemented RBI, risk-based inspection programs, have sparked WorkSafe's attention. And we were keen to understand if there's been any change in performance over the time for the sites that use these RBI programs for asset integrity inspections versus those sites that rely predominantly on standardised inspection programs as recommended by codes and standards. What we found was that sites that use predominantly RBI-based inspection programs to manage their asset integrity were 3 to 5 times more likely to have an asset integrity-related incident than those that do not. However, whilst it's really tempting to try to compare these two curves and draw some conclusions here, these two lines are not comparable. Given that the sites that adopt RBI programs tend to be larger and more complex facilities, it's really like comparing apples and oranges. What we can do, however, is look at each of these curves independently and compare previous performance with current performance. Those sites that use predominantly standardised inspection programs, as we see along the bottom here, have pretty much maintained a steady and low asset integrity notifiable incident rate since 2010. For those sites that use RBI-based maintenance programs, we can see on average there was a steady decrease in notifiable incidences between 2010 and 2016. However, in 2017 and again in 2019, we saw a substantial increase in asset integrity notifiable incidences that had not been recorded since 2010 and 2012 respectively. This is also backed up by the data that we've collected through annual inspections, where in the last 4 years, we have seen a slight decrease in performance for asset integrity related inspection points across these same facilities that predominantly use RBI-based inspection programs. Over the next few years, WorkSafe Victoria are going to continue to focus on these asset integrity related notifiable incidences to see if this upward trend continues. Our team will also be further focusing on future annual inspection findings for asset integrity in a more detailed way to understand some of the key issues in this space. Whilst as the regulator, we understand that risk-based inspection techniques can reduce cost for large and complex major hazard facilities, particularly when that's used to justify extending inspection intervals, it's important that this does not come at the expense of process safety. Whilst RBI was initially created to optimise plant utilisation and increase uptime, a good and well-structured RBI program can also have indirect safety benefits. As an example, by limiting the exposure of people in the plant doing unnecessary maintenance. We often see RBI risk tolerance being used to extend inspection intervals, but using the same argument, we would expect to see a tipping point at some point with RBI programs, where inspection intervals should be decreased when necessary, particularly as assets age. It's an area that's currently got our attention and will likely be a focus of future safety case assessments for sites that use predominantly RBI-based programs. Given that Albert has talked about the establishments of the regime, its growth over the last 20-odd years, and some of the improvements that we've seen over this time, which was also supported by the data that we collected, as I've just gone through, before we wrap this up, it's probably worth touching on our plans as the regulator in terms of what we're going to do moving forward. There's still a lot more to do in our data collection and analysis. We'll be looking to further refine our current data, particularly the information we collect from annual and verification inspections, to a level of detail that will allow us to identify more specific trends in this space. We also want to integrate additional data sources we have, such as the results of safety case assessments and maybe some oversight data that we collect during licensing periods. We'd also like to investigate the potential to tap into external data sources, such as those collected by FRV, EPA, and even individual major hazard facility sites. We want to use the data and our findings to provide learnings back to the industry, maybe in the form of newsletters, such as Major Hazard Facility Matters, guidance notes, safety alerts, or communications directly to sites. And finally, we'd like to figure out a way that we can use it as a means of identifying emerging issues and set priority areas for focus for the regulator teams, just like the RBI example that we touched on earlier. On behalf of myself and Albert, we'd like to thank you for your attendance today and listening to what we had to say about our 20 years of evolving regulatory practice. If you have any questions, please feel free to contact us. Our details are on the screen now at the end of the presentation, and you'll still be able to access these presentations for 2 months after the forum, so you'll be able to note them down then. Thanks again, and it's now time for me to hand over back to Yvette.
Thank you, Albert and Jaime. It was fantastic to see from the data how the Major Hazard Facility Regulatory regime has evolved over the past 20 years and the role incidents, technology and legislation have played in shaping that journey. Coming up, we will hear from NOPSEMA's Derek O'Keefe, who will be discussing deferred maintenance. See you shortly.